Right. So, in case anyone hasn't seen it yet, I did finally get around to posting on the Canvas site. So if you go to modules, class video link, and then you can actually just click on the link right from there. Takes you right to the class videos that I've recorded and posted already. Trying to do it the other way where I posted everything on Canvas. Canvas actually has a limit in the amount of crap I can put on there, and I reached that limit. So it wouldn't let me do any more. Then on top of that, there was spending like 6 minutes to actually download the videos to get them onto my computer so I could then go to Canvas and then try to upload them onto Canvas, which would then take 15 minutes. And then for it to go, we're too full. No. So it's like, all right, now what? So you can watch them all on YouTube. And as a reminder, if you are going to be watching these videos, make sure you watch them at like 1.5 speed at least. Unless you're having a really rough night and you want to fall asleep, then put it at like 0.75 and you'll be out after what, 30 seconds. And for some of you just listening to me at one time speed are going to be out in what, 10 minutes. So it works out well, right? And in the past, I have made jokes about try not to watch these videos when you're, say, on a break at work or, say, sitting on the toilet at home, because you will pass out. And then one of my students actually did watch him on his break, and he did fall asleep and then woke up 2.5 hours later to his manager standing in front of him. Get up. What's wrong with you? So it does happen. If you don't care about that particular job, fine, do whatever. But if you actually want to keep working, or if you need that job, don't watch these videos at work. So today is February 25th. So we get to go through 7.1 and 7.2. And then 7.3 and 7.4 on Thursday. And then you get to have winter break, spring break, whatever they want to call it. Because spring happens the first week of March, right? Yeah, I don't get that either. But that's when we're having it. So this week we do stuff. Next week we have time off, and then you can see that test number 2 is actually coming up. So we will, on the 13th, again, we will have a review. It will be student initiated. It will be on all the stuff that we've covered since the previous test. So you can see it covers section 4.4. So that's the x plus y plus z, three equations, or 3 unknowns, solve for x, y, and z section. Chapter 5, 6, and 7, excluding 7.5. So solving applications with rational equations. Yeah, we'll see what types of applications they actually come up with on here. Some of the stuff that we're going to do is a bit more, or is a lot of the same that we were doing the last 2 class periods. So if I go over something a little bit too quickly and you're wondering where that's at, well, it's because I went over it a whole lot more quickly over one of the last 2 class periods. So you've got those videos and you can watch them. But what we're going to be doing a lot of in here is multiplying and dividing. And as you can see, multiplying and dividing, everyone's favorite. You all love fractions, right? Fractions make you happy. Or at least fractions make everyone smile, right? Because the meds are starting to wear off and you're starting to go mad. Yeah. So we're going to be dealing with a lot of problems like these. So looking at just what the first three problems here are asking. And this is something that probably need to review a little bit for or based on the first exam that we had. So it says determine the value for which each rational expression is undefined. If we're looking at this first problem right here, the only variable that we need to really care about is C. What value of C can I put into the denominator that will make the denominator equal to 0? 0, right? 3 times 0 is 0. I don't care what A and B are at the top. I only care about C. So in this case, we're going to say C cannot equal 0. Easy enough, right? Looking at the next one here, 2b plus 5. What value of b can I shove in there to make the denominator equal to 0? A little bit more complicated, but not too bad. So I'm going to write this. I'll write this down on my paper here. So 4b minus 3 divided by 2b plus 5. So on this one, come on. Come on. You can zoom. You can zoom in. Don't be afraid. And don't go the other way. Great. Anyway, so with this, what we need to be worried about is at what point does 2b plus 5 equal 0? So we need to solve for b. Come on. Is there... Of course, there's not going to be another version of that on here, unless... So the is now actively fighting me. Awesome. Always appreciate it. So anyway, when b is equal to negative 5/2, if we want to write what value makes it so that this equation up here, this function up here does not exist. B equals negative 5/2. So if we're getting back to some of the stuff that's on the exam that some of you kind of forgot about, if we're trying to figure out, if I want you to write in, say, interval notation, what are the possible values of b that'll work in this equation? You'd say negative infinity to negative 5/2. You need to use the rounded bracket, and then union negative 5/2 to positive infinity. If you use square brackets on here, again, square brackets means it can equal. Round brackets means it can, what we call in, or we say in calculus, it can approach the value, but it can never touch. If we try to graph this just to see, maybe we need to check ourselves and see what's actually going on. Can pull up our graphing calculator, go to Y, need to clear this stuff out. And with an equation like we have here, or with the function or whatever it is we're dealing with up here, if we're going to put or try to graph this, we need to recognize that we need to put parentheses to open it, then 4x minus 3, close parentheses, divide. again, open parentheses, 2x plus 5, close parentheses. And I will just say right here and right now, the way that I have it on the screen, it will work right. If you don't put those round brackets in the spaces where I've got the round brackets, you will get something, it just won't be the right something. And I say this knowing that the stats class that I'm going to be teaching on Wednesday night, we will have some functions like this, and I will have to tell them explicitly, make sure you put brackets. And then what happens on the exams, they don't put the brackets in, they get really weird, wrong numbers. And then they're like, I don't know what happened. You just have to look at them. Brackets. So now that I've got the brackets on there, I can graph this. And it's kind of hard to tell by looking at it. But if you notice, if we start off on the left and we start moving right, all of a sudden we've got like this asymptote, which is like right around here. We start on the right, start moving left. All of a sudden the value takes a sharp nosedive, which is another one of those asymptotes. If we had a really good graphing feature on here, we could actually go in and try to figure out what that value is. But again, let's say we're dealing with the equation as it's been written, and you're trying to figure out what value b can I not have. Since this goes off about here, so somewhere between -2 from here, bring this down to say somewhere between -2 and -4. Is -5/2 in that range? Yeah. So we can try to feel good about the value that we've got there. When we're looking at something like C, C can actually be fairly difficult, or it can be fairly weird. The way that this one is actually written out, what you're going to have is they're going to be in the denominator. When we factor this, there's going to be 2 values of x that we're not allowed to have. On the top, you're going to have x plus 4. The denominator doesn't have an x plus 4 in it, which means we're going to have 2 different values of x we need to worry about. So with this, we know that, or we should at least guess that there's probably going to be 2 values of x that we can't have. But we always need to do the math to actually see what's going on. Okay. So we got x plus 4 over x squared plus 5x plus 6. So I have to find an expression for where this is undefined. So what are the values of x where x squared plus 5x plus 6 equals 0? If you look at this and you kind of see what the answer is going to be already, we can actually break this down as x plus something times x plus something else equals 0. In this particular case, how do I know that it's going to be x plus and x plus? Well, I've got a positive value there. I've got a positive value there. That tells me it's going to be plus and plus. If I had positive value there and a negative value there, because one of these values is negative, that's going to tell me I'm going to have at least one negative value of x. And if I have a negative value there and a positive value there, negative times a negative is a positive. That means I actually have to write this up. Would have in that case, would have to write it out as x minus something times x minus something else. Again, with this, if you see it, awesome. If you don't, that's okay. But when we factor it, that's what we're going to get. If you don't see it, we can always use our formula. Here, A equals 1, B equals 5, C equals 6. So we've got -5 plus and minus the square root 5 squared minus 4 times A times C. All of that is divided by 2A, so 2 times 1. So -5 plus and minus the square root 25 minus 24 divided by 2. 25 minus 24 is 1. -5 plus and minus the square root of 1 over 2, just -5 plus and minus 1 divided by 2, which gives us -5 plus 1, so -4 over 2, -5 minus 1, -6 over 2, so that gives us -2 and -3. And when we use this formula, these are the values of x that make the denominator go to 0. So when we factor it like this, we have to take whatever these values are and do the opposite, because -2 plus 2 is 0. -3 plus 3 is 0. So in the case of this equation right here, of x plus 4 over x plus 2 times x plus 3. What are the values of x that we cannot have? X cannot equal -2 and -3. So if we write this in interval notation, -infinity to -2, union -2, -3, union -3 to would be positive infinity. And I ran out of space on there, so sorry about that. And this particular formula, we're going to be using it if we use it on every problem that requires it, probably about 50 times today. So now if we look at an example problem like 7.2 here, it says how to simplify a rational expression. We factor the top, we factor the bottom, and you can kind of follow along here. The top and the bottom are both going to have some term that's the same, so you can cancel them out and then end up with whatever value we happen to be going with. So if I look at 7.4, got x squared minus 3x minus 10 divided by x squared plus x minus 2. And with both of these, what this is trying to tell me is that there should be an x plus some number and then x minus a number, both top and bottom. So looking at this, we can plug everything into our equation here if we needed it. If you go and you put in all the numbers, you're going to figure out what the values of x are that we need to plug in here. If you see the easier way of doing it, two factors of -10 that when you combine them gives you -3. It's basically a -5 and a +2. If you don't see that, again, plug the numbers in over here. B is going to be -3, A is going to be 1, C is going to be -10. Go through all of this to get the values of x that we can't have. In the denominator here, again, looking at what we have here, and hopefully by now you've all seen enough math problems to know that a lot of times if you're going to have something like this, there's going to be something on the top you can cancel out with something on the bottom, right? So without, just by looking at what we have here, and without trying to do anything, what do we think is going to be canceled out here? X plus 2 or x minus 5? X plus 2. How do we know it's not x minus 5? Because we don't have any multiples of 5 over here. So, again, if you see what the answer is here, awesome. If you don't, that's cool. Plug in your numbers over here. I will be using this formula a couple more times, but a little bit later on. So we've now got it set up the way that it is here. Got x plus 2 in the numerator, x plus 2 in the denominator. Those will actually cancel out. And our answer is just going to be that. It's not necessarily the type of answer that for a lot of you when you're going to be doing the homework problems or when you're going to be doing the exam problems, you get something like that, you're going to be, what's your first thought going to be? What else should I do? What's the value of x for this? In this particular case, there is none. But a couple of the things that are going to come up with a problem like this, and if you are doing the online homework, these are some issues that you might actually run into. If we're asking what are the values of x that we're not allowed to have here, based on this equation right here, you can't have x equals -2 and x equals a +1. So if this problem was to come up with the online homework, and it's asking where does the what values of x make the denominator equal 0, you'd have your two answers. You could put them in. It might accept both of them. It might tell you that you're wrong. What's the reason for that? Since I've got x plus 2, once I factored on the bottom, x plus 2 factored out at the top, I might need to cancel those out. So if we're looking at the type of problem like we have on here, where it's asking, or well, actually here it's just telling us to simplify. But then we're not allowed to have certain values in the denominator. So you can see kind of what the textbook is telling us here. Even though the answer is this x plus 3 divided by x plus 6, we're not allowed to have x equals -6. We're not allowed to have x equals -2. Even though we canceled it out, still telling us we're not allowed to have that. Is that because the textbook does it that way? Does that mean the online homework is going to do it that way? You're the ones doing the online homework, not me. Is that how the online system wants it? Yeah, I have faith that the system you guys use is a lot better than some of the ones I've used in other places. But I'm not certain. So bare minimum, the answer is going to be x cannot equal -6. They may want you to put x cannot equal -2 in there as your answer as well. That might cause some issues. So if you have a problem like that, something like that comes up, uh, you may need to go back, or you may need to unfactor everything and check it, or you may need to factor everything and check it. So looking at the example problem that we have here, again, we're going to try to factor out some things. If you look at the numerator, it looks like some of the more complicated quadratics that we were dealing with last time. The denominator, if you can see it, you can see it really well. That's actually similar to one of the special forms that we were dealing with last time. If you can't see it, not a big deal. We can still handle it. Factor everything out, and you can see kind of what's going on with all the rest of the stuff down here. I know, totally riveting and extremely exciting stuff that's going on. But if we look at 7.6, got 5x squared minus 30xy plus 25y squared. All of that's going to be divided by 2x squared minus 50y squared. I'm going to make sure I've got all this stuff copied correctly. So with both of these, we already know that we're going to have x plus some number times y, and then x plus some number times y in the numerator as well as the denominator. How do we know that? Well, one, there's an x squared term, so we're going to have the x's out in front. Because there's a y squared term, we're going to have the y's at the end. If we only had, say, x squared plus xy plus y, then we just get to cover up one of these y's at the end here. So looking at what we have, are there any values, numeric values that we can actually pull out of all three of these numbers here? Hopefully you see that we can pull out a 5. So our first step is to pull out the 5. X squared, -30 divided by 5, -6. 25 divided by 5 is going to be 5y squared. In the denominator, hopefully you see that we can pull a 2 out of both of these. That's going to give us 2x squared minus 25y squared. If we're going to factor the denominator, we've got a couple options here. We can look at this and we can pretend that it's actually that, set that equal to 0, figure out what the values of x are, plug them in up here. If you don't feel comfortable with that, or if you happen to see an equation like this, say on the exam, and you're trying to figure out what to do, we can do this, or instead of trying to plug everything into -b plus and minus the square root of the quantity b squared minus 4ac, and then all of that divided by 2a. we can make it easy. We like making things easy, right? When we can. We agree on this? So I can bring this to the other side. That's going to give me x squared equals 25y squared. How do I get x by itself? Take the square root. So if I take the square root of one side, I have to take the square root of the other. Going to end up with x. And we have to keep in mind that whenever we take the square root of something, there's a positive as well as a negative value. We can have that. And because everyone so totally remembers everything that we went over, what was it, 2 weeks ago, something like that, we know that we can pull these apart like that. Square root of 25 is going to be 5. Square root of y squared is going to be y. So our denominator, x plus 5y, and then x plus a negative 5y. So we should probably try to rewrite that. In the numerator, we've now got this. What are two values that when you combine them or add them together, you get -6. But when you multiply them together, you get a +5. Yeah, if you see it automatically, awesome. If you don't worry about it. But if we look at this as -5 and -1 to give us x minus 5y, x minus 1y. This will actually cancel out with that. If you don't see where I got this, then with this, you're going to be stuck with setting that equation equal to 0. You're going to get x equals -b, so -6, plus and minus the square root, -6 squared minus 4 times a times c. All of that is going to be divided by 2 times a. Negative times negative is a positive, so 6 plus and minus the square root, -6 squared, that's 36, minus 4 times 1 is 4, 4 times 5 is 20. All of that, 2 times 1 is 2. 6 plus and minus square root of 36 minus 20 is going to give us 16. 6 plus and minus 4 divided by 2. And then that's going to give us 6 plus 4 over 2, and 6 minus 4 over 2. 6 plus 4 is 10. 10 divided by 2 is 5. 6 minus 4 is 2 over 2. So that's going to give us 1. And again, when we go to factor it, we have to take whatever numbers we have here, plug them in up here, but we have to use the opposite value. And if you're looking at that problem and saying, that looks like it's a bit much, by now you should realize this is math. It's always going to get worse, right? We can admit that. That's not a surprise to anyone. Well, next, a little gimmick thing that they're trying to do here. This is something that we're going to use a couple of times in the next section. When we look at the numerator, we have x squared minus 4x minus 32. So x squared is out in front, x squared is positive. Down here, x squared is not out front, and x squared is also negative. So the key for this particular problem is to recognize we can pull out a negative. Now, since they're already going to do it, I'm not going to worry about it. But ooh, and look at that, to even kind of jump the gun a little bit and then bother to show you what ends up happening when you pull out the -1. So when you multiply the denominator by -1, you get -64 minus, but you have to distribute the negative, so negative times a negative is a positive. So the next step here should be x squared minus 4x minus 32 divided by x squared minus 64 and a negative out in front. So if we look at, say, problem 7.8, we have x squared plus x minus 2 over 1 minus x squared. And just a reminder that this is the same thing as that. Because I've got the -1 in the denominator, I can actually bring the -1 out in front. And then we get to solve x squared plus x minus 2 over x squared minus 1. If you look at this, again, you recognize this as one of the special forms or special formulas that we had last time. If you don't see it, you can plug everything into the equation that we've been using. If you want to make your life easier on this and you're not sure, since we have to factor it, we're going to be saying x squared minus 1 equals 0. Add 1 to both sides. Gives us x squared equals 1. How do I get x by itself? Take the square root of both sides. So that's going to give me x equals plus and minus square root of 1. So plus and minus 1. So that's what we get when we factor the denominator. Looking at the numerator, we know that there's going to be an x and an x. And this is telling me that at least one of these values is going to be negative. One of these values is going to be positive. Now we need to try to figure out how we can factor these. If you see it automatically, if you see it already, you're going to look at that and say x minus 1 and x plus 2. Where does that come from? 2 minus 1 is 1, but -1 times a positive 2 is a -2. So if you see it, we're talking about this the last time. If you have a better way of doing it or a faster way of doing it, go right ahead. If you don't see it, A equals 1, B equals 1, C equals -2. Plug them into that other formula and go about it. Also got to remember that there's the negative out in front. Now we have x minus 1 and x minus 1. Those cancel out. So that could be our answer. So again, if on the exam, if you have a problem like this, and that's the answer you give it or give to me, and that's the way that you give it to me, I'm totally fine with that. Because I'm totally fine with that. Does that mean that the homework on homework stuff is gonna be totally fine with that? You might need to put the negative out in front. Like that. Here, I've basically got the negative on the numerator. Here, the negative is kind of out in front, so you know it does something with either the numerator or the denominator, just not both. So I don't know how the online homework system is gonna react to a problem like that. But those are the answers. So if you put the bottom one in and you get it marked wrong, try putting the top one in. If you put the top one in, you get it marked wrong, try putting in the bottom one. If both of those are wrong, um, hopefully there's a little button on there you could click on and say, hey, this isn't gonna, or this isn't accepting the correct answer. It's totally possible. When I say it won't accept the correct answer and it's totally possible, what do I actually mean by that? What are the chances that there's going to be a wrong answer with the online homework? Anybody want to guess? Depending on how it was written, I've actually seen some online homework systems where quite literally uh, there's like one or two problems per section that uh, it it wants the wrong answer. So, and everyone here hates fractions, right? And as I say fractions, I just saw how many heads just look up and go, oh, wait, what? So if we're multiplying and dividing fractions the way that we're doing it here, it's actually not too bad. It's not the nicest, it's not the easiest, but it's not too bad. With all of these, what you're going to find is that anytime we have like these quadratic, or some of these will even have cubic things popping up all over the place, uh, you need to factor out something first. Going through what they're doing here, they're going to factor x squared minus 9, and then they're going to factor x squared minus 7x plus 12. That's where all these things come in. Collect the like terms, cancel out things you can cancel, and be done with it. So if I'm looking at 710, so I've got 9x squared over x squared plus 5x plus 6 multiplied by x squared minus 36 divided by 3x squared. Now, are you trying to say I have dyslexia sometimes? Or that maybe sometimes I'm just way too tired while I'm trying to do math? That's your excuse for when you get problems wrong on the exams, right? I know how to do it, I was just too tired that day. So I guess that means bonus points for everyone in here. And we are going to have a in-class problem too. So looking at these, I'm looking at this one way and I'm seeing 9x squared and then 3x squared. I kind of want to rewrite these almost instantly. Like that. 9 on the top, 3 on the bottom. It's going to give me a 3. X squared on the top, x squared on the bottom. It's going to give me nothing. Now we need to factor these. If you notice that this is in that special form, you can factor it instantly and easily. Here, because I've got a positive and a positive, I don't know what these values of x are going to be, but I do know that the denominator is going to be x plus something times x plus another something. We are kind of hopeful that we can cancel out something on the top here with something on the bottom. Since we know that both of these are going to be positive, hopefully we can factor out an x plus 6. Sometimes we can, sometimes we can't. With this one, if you look at it and you know, and you can see it instantly, 5 plus 6 is 11, 5 times 6 is 30. Factored, yes. If you don't see that instantly, A equals 1, B equals 11, C equals 30. Well, I'll start doing some of these when we have like a 4 and a 7 and stuff like that out in front here. But with some of these, if you got the alternative methods, that's cool. You can cancel those out. So what's left? So we just multiplied those across and canceled out everything that we possibly could. And then something that doesn't look nearly as nasty popped out of there. Now, I'm sure that a lot of you have had enough math classes by now to know what's going to be coming next, right? If we're multiplying fractions, what's the next step going to be? Dividing fractions. So here, this one's actually a little bit more complicated. But then we get to dividing fractions. Yay, almost, right? So we'll take a look at 712 real quick. So again, this is multiplying. We need to factor numerators and denominators and everything. So 4b squared plus 7b minus 2 divided by 1 minus b squared. Multiply that by b squared minus 2b plus 1. Divide that by 4b squared plus 15b minus 4. So I'll just try to make sure I actually wrote those down right. So with this, first thing we can do is pull out the negative and have b squared minus 1. Up here, when we factor that, so with something like this is where things get a little bit weird. we could totally have, or when we factor this, we could have it where we have 2b plus something times 2b minus something. How do we know we're going to have a negative in there? Well, because there's a negative right there. How do we know that there's going to be a positive in there? Because that's positive. The other option is that we could have 4b plus something times b minus something, or 4b minus something times b plus something. Now, when it comes time for the online homework with both of these options here, if when we factor, this is what we're actually going to get. The way when we factor it, when we plug everything into our formula, we're actually going to get b plus some number over 2, and then b minus some other number over 2. With both of these, you're going to have b plus something over 4 and b minus something over 4. So again, when we're looking at the exam, if you give it to me like this, or just b minus something, b plus like b minus a fraction, b plus a fraction, whatever it happens to be, I'm totally fine with that. What's the online homework going to want you to do? I don't know. So with this, again, change it over to x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. So negative 7 plus and minus the square root 7 squared minus 4 times a times c divided by 2 times a. So negative 7 plus and minus the square root. 7 squared is 49. 4 times 4 is 16. 16 times 2 is 32. Negative times a negative is a positive. 2 times 4 is 8. So negative 7 plus and minus the square root of, so what's 49 plus 32? It's a calculator problem, isn't it? So here we now have negative 7 plus and minus square root of 81. It's going to be 9 divided by 8. So negative 7 plus 9 divided by 8. Negative 7 minus 9 divided by 8. Negative 7 plus 9, 2 over 8. We can reduce that and turn it into 1/4. Negative 7 minus 9, negative 16 divided by 8. That's going to give us negative 2. So when we go to plug these things in, we know that up here, when we factor it, I can get b, since I got plus 1/4, minus 1/4. Since I've got a minus 2, that is now factored. b squared minus 2b plus 1. If you see what's going on here, what times what will give you a positive 1, but when you combine them together, it gives you a negative 2. Those are the negative ones. We have to now factor this. Because I've got the 4 out in front here, more than likely, that's going to be the thing that we need to factor out. So b minus 1/4. If you look at how the textbook tries to write out b minus 1/4, they write it out as for exam purposes, I could not care less which one you give me. Just give me one of them. For online homework purposes, most likely that's going to be the one that you're going to have to go for. Okay. Just something to be prepared for, something to know is going to be coming your way. With this b squared minus 1 thing, that's one of the special forms. So we know that it comes out to be b minus 1 times b plus 1 over here. If you don't see what this is going to break down as instantly and immediately, I don't either. So I have to come in here, x equals negative b, so negative 15 plus and minus square root of 15 squared minus 4 times a times c divided by 2a. So negative 15 plus and minus the square root. 15 squared. Anybody know what 15 squared is right off the top of their head? Yeah, I don't either. Even though it's 11:30, it's still too early in the morning for that sort of stuff, right? So 15 squared. So we get 255. Or sorry, 225. Negative times a negative, that's going to be positive. 4 cubed, 64 plus 225. That's all going to be over 8. So negative 15 plus and minus the square root of 289 divided by 8. The square root, so second, and then I can even do second and then answer. So this turns out to be negative 15 plus and minus 17 divided by 8. Is anyone else tired of this problem yet? Or is everyone already passed out from the problem? So we get negative 15 plus 17 over 8 and negative 15 minus 17 over 8. Negative 15 plus 17, 2 over 8. So that's 1 over 4. Negative 15 minus 17, that's going to be what? So we now know that over here, and are we even done with this yet? No, no, we're not. So multiplying these together, Have we even multiplied them together? No, we factored a lot of things. We haven't multiplied anything yet. But now I know that I've got a b minus the fourth on the top, b minus the fourth on the bottom. Those cancel out. B minus 1 on the top, B minus 1 on the bottom, those cancel out. What's left over on the top? I know this is going to look a bit weird, and I'm sorry for that. We have B plus 2 times B minus 1 divided by the negative B plus 1 times B plus 4. So how many of those types of problems do you think are going to be on the exam in a couple of weeks? 2 or 3? So I know that was a lot, but it all comes down to what? Factor everything, cancel everything you can, then multiply at the end. What would end up happening if, say, you didn't cancel first? Does anyone even want to contemplate how horrible that would be? Just think about it. If you didn't cancel it first, 4b squared times b squared is going to give you what? 4b to the fourth. 4b squared times negative 2b. So 4b to the fourth minus 8b cubed. Dear God, what are we doing? Multiply everything out, then try to factor it. No, just no. So what's the rule for this? Factor, then multiply. And then, of course, we get into problems here where we are dividing. Does anybody remember what happens when you divide fractions and how that actually works? If you do, awesome. If you don't, just a quick refresher. If I have A divided by B, or over B, divided by C divided by D, it's the same thing as saying A divided by B times D divided by C. Where does this come from? Well, what this is telling me to do here is that A over B, then big fraction line or big divisor, C over D. If I want to eliminate the denominator or the fraction in the denominator, what do? Multiply by the reciprocal. If I do it to the bottom, got to do it to the top. D cancels with D, C cancels with C. That gives me AD divided by BC, which is what I've got there. And it won't let me zoom in. Oh, well. Now, looking at what we've got here, you've got P cubed plus Q cubed. If you go back a section, there's some special factoring things that you're supposed to remember for P cubed plus Q cubed. Do I remember them? No. Why not? Basically in anything and everything that I've ever done, I've never actually had an equation come out that looked like that before. So kind of don't commit things to memory that I don't use. However, I'm not going to be the one taking the exam in 3 weeks. So it's something that you guys are going to need to memorize, at least most likely. But looking at what they're doing here, take the second part, flip it over and multiply. Then they factor everything out. And p cubed plus q cubed ends up coming out to be this formula here. So p squared minus pq plus q cubed. When you factor all one of these things, you get pretty much the same thing. Cancel everything out, then multiply at the very end. So if I'm looking at 7 14, I've got 2z squared divided by z squared minus 1 divided by z cubed minus z squared plus z divided by z cubed plus 1. Now, keeping in mind what happens when we use that special formula, p cubed plus q cubed becomes this whole thing right here. So put this off on the side for the moment. So first step, flip this over and multiply. The next step, try to factor as much of the stuff as possible. Not much we can do here. Up here, this is the same as p cubed plus q cubed. So p plus q times p squared plus, oops, should be a minus, pq plus q squared and then with the denominator here, z squared minus 1, z minus 1, z plus 1. Up here, I can plot a z. So we have z squared minus z plus 1. Z plus 1 cancels with z plus 1. Z squared minus z plus 1 cancels out with that. So what's left over here? So far, we've got 2 z squared over z minus 1 times z. Z in the denominator, z squared in the numerator. That'll cancel out with that. So final answer, so that was a thing. Of course, there's always more. So if we have something like that, what do we do? Factor it, try to cancel out as much stuff as we can. And then what are we going to end up doing? Taking whatever this is, instead of dividing by this whole thing, bring it out and multiply by that whole thing. So if we're looking at, and usually both of these are pretty horrible looking. So let's look at 716. So we got y squared minus 36 divided by 2y squared plus 11y minus 6. That whole thing is divided by 2y squared minus 2y minus 60. Then that is divided by 8y minus 4. And is that a lot? Yes, that is a lot. Is it horrific? Yeah, pretty much. So what's our first step going to be? Y squared minus 36 over 2y squared plus 11y minus 6 times 8y minus 4 over 2 y squared. I am flipping that over correctly, right? Did I copy that down wrong? Or is the book just giving us a curveball here? No, the book hates us. Can anyone else tell that? So what's going to happen? Take this, flip it over. The 2y squared thing and it's going to be multiplied by the 2y squared thing. So hopefully we can cancel out a whole bunch of stuff. Otherwise, this is going to be horrible. So in this case, the book is literally messing with us. If we look at this one here, you've got 3x squared and 3x squared. When you flip it over, the whatever has the like x to something over 3, it's going to cancel out with each other. Down here, no, that'd be too nice. That'd be too convenient. So let's get to it. Looking at the top here, again, this is one of those special forms. Here, I've got an 8 and a 4. I can do a couple different things here. Because I've got 8y minus 4, what's a value that they both have in common? So I'll write this out a little bit bigger over here. 8y minus 4, what's the value that they both have in common? Oh, 2. They also have 4 in common, right? So let's say we see that and we go, well, I can pull out a 4. So I can actually pull it out like that. What's another thing that I can do that is literally the same thing as that? What's the value in front of the y? I can do either one of those things. Just looking at what's going on over here. If we use the books method, this 2y minus 1 is going to be something that we cancel out down here. If we go through and we do x equals negative b plus blah, blah, blah all the way through, this is going to be the one that we get. So we need to just recognize right here that these two things are actually interchangeable, okay? So I'll go with the top one for now. Like I said, we have to keep in mind that these things are going to be interchangeable. Down here, we're most likely, because of what we've got here, we're most likely going to get a 2y plus or minus something, and then y plus or minus something else out here. Same thing over here. If we factor these, so y equals -11 plus and minus the square root of 11 squared minus 4 times a times c divided by 2a. So we can go in and do that. Anybody want to cheat a little bit? Just a little bit. What have I, with everything that we've been doing at the beginning of the class, especially for the first exam, what have I been trying to tell all of you to do? Graph it, then math it. So let's graph it. So we want to look, or we want to come out and graph try to get all this up so that we can all see it. So I'm going to go to y squared, or to y equals, clear that out. So 2y squared, so because the way the calculator is set up, that's now going to be 2x squared plus 11x minus 6. And we also need to graph this next thing. So I can drag that down. And again, we have to do this as 2x squared, not 2y squared. Minus 2x minus 60. Oops. So now if I graph these, does that look a lot nicer? So the blue answer, or the blue graph, is the thing on top. Because there's a 2 there, we know that's going to go through a half. So what half is that? Half, 1.5, 2.5, 3.5, 4.5. It's basically a half, right? So I'm going to try to write all this stuff down. Y minus 6, y plus 6. All that's going to be divided by y. Since it's plus a half, we have to subtract a half. And then y for the blue one, -1, -2, 3, 4, 5, 6. So we have y plus 6. And then just because I just pulled out the y minus 1/2, I'm going to actually change my vote for what we do. For the denominator, oh, have you pulled something out of here? There's a 2, 2 and a 60. Can we factor a number out from that? And pull out a 2, right? So this problem is just messing with us in all sorts of ways. Well, what happens when we factor it? We get x equals 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So 6 and -5. So we know that we're going to have y minus 6, y plus 5. And so far, all we've done is what? Just factor everything. That's all we've done. Ugh. Now we're here. Y minus 6, y minus 6, y plus 6, y plus 6, y minus a half, y minus a half. And what's left over? 8 divided by y plus 5. So, has anyone had enough of that type of stuff yet? Don't worry, it gets worse. It always gets worse, right? Look at that beautiful thing. Anyone else want to just pop chuck a whole lot of whatever you had for breakfast looking at that? Even with the problem like this, what are we going to do? Factor as much stuff as we can. I can pull a 3 out of both of these. I can pull a 4 out of both of these. Get that out. Factor that. Factor that. Instead of divided by this, flip it over. I can pull an 8 out of both of these. I can pull a 2 out of both of these. Cancel a whole lot of stuff. And then hopefully we get some happiness. Or something that doesn't look as disgusting as what we've got on the screen right there. Looking at some of the other stuff that's in this section. So here where it's saying find the domain of r of x equals, and then we've got quadratic divided by a quadratic. Again, for the domain, those are values of x. What values of x are we not allowed to have? Whatever's in this denominator, set that equal to 0, solve for x. If you notice that you can pull 4s out of everything, pull the 4s out of everything, factor it. If you don't notice that, plug it into the equation and move on. And then if we're, so here we've eventually come up with x cannot equal 6, x cannot equal -2. For this particular type of problem, if you were to do the in interval notation, -infinity to -2, union -2 to +6, union 6 to +infinity. So there's going to be 3 different sections. Because this is a lot of the same type of stuff we've already been doing, I'm not going to bother with these. Now we've got some more division, some more multiplication. Same thing we've been doing before. And then in the next, 25 minutes, we're supposed to go through all of 7.2. Yay. So 7.2. 7.2 is actually, well, half of it anyway, isn't too bad. Adding and subtracting fractions. Do we like fractions? No. But if we are going to be dealing with fractions and we're adding and subtracting fractions, what's step 1 going to be? Hit the same common denominator. Once you have the same common denominator, you can see from the example problem here, combine everything, factor the top, cancel top and bottom, and eventually you get the answer that you're looking for. So if we look at say 726, x squared plus 8x over x plus 5 plus 15 over x plus 5. Same common denominator. So there we go with that. It's all going to be over x plus 5. Factor the top. Since we've got an x plus 5 in the denominator, we're probably going to pull an x plus 5 out of the numerator, right? And there's our final answer. Now, what would happen if, say, we subtract fractions? How would this change? We'd have the same process, except over here. So if this became a negative, factor the top, factor the bottom. Is there anything we can cancel out? In this case, the answer is going to be what? Yes or no? No. So factor the top, factor the bottom. We've already, with this one, you would actually want to use the formula that we've been working with. See what I tell you? What's the next thing on here? Subtracting. Now, looking at what's going on here, again, the denominators are the same. The numerators are different. I will tell you that when you start doing a problem like these, say on the exam or on the online homework, that negative distributes to everything. So you end up with 5x squared minus 4x squared, negative 7 minus x, or negative 7x minus x. 3 minus negative 9. Negative times a negative is a, so 3 plus 9 is, so factor that. Anyone else tired of factoring things over and over and over? Anyone? Yeah. Don't worry, it's about to get worse, but not too much worse. So again, we notice the denominators are the same. Here, big issue here. Pull a negative 1 out of here. Negative times a negative becomes a, so the numerator you'd have m squared minus 6m. Negative times negative is a positive, so plus 3m plus 2. The denominator is going to be m squared minus 1. You can kind of follow along with what they're doing over there. So negative times a negative is a positive. Negative times a negative is a positive. Combine it, factor it, you're done. I'll just make that a positive, and it's going to be y squared minus 4 on both sides. Now here is where it gets horrible. Least common denominator. How do we handle this? We have to factor both denominators. Whatever is the same, that makes it in, and then but it only makes it in one time. And whatever is different makes it in. But then the next step here is going to be what? Adding and subtracting these things, right? So Just looking at this first one here, we have 2 over x minus 2 plus 5 over x plus 3. The big deal, the big idea, the big thing we need to worry about here is making a common denominator. Our common denominator, just because we don't know anything different at this time, just take that, multiply it by that, and there you go. It's not that bad. Here's where it gets confusing. Here's where it can be a bit tricky. X minus 2 times what gives me x minus 2 times x plus 3? Well, I've got to multiply both sides. So 2 over x minus 2. But then multiply numerator and denominator. So that's going to give me 2 times x plus 3. Since I've got a plus here, we're going to add. Then there's going to be the 5. So I have 5 over x plus 3. How do I get it to be x minus 2 times x minus 3? Have to multiply numerator and denominator by whatever the other thing is. Next up here, FOIL or distribute everything. So 2x plus 2 times 3 is 6 plus 5x, 5 times negative 2, negative 10 over x minus 2, x plus 3. Join the similar values here. So what happens if that's going to be a negative? Well, that's going to be a negative. So you distribute a negative 5. 2x plus 6 minus 5x plus 10. Big deal. Okay. So if we're looking at this one, to get the common denominator, it's going to be m plus 3 times m plus 4. Because this already has m plus 3, I'm going to multiply the numerator here by m plus 4. Because this already has m plus 4, I'm going to multiply the numerator here by m plus 3, then distribute. If we've got something like this, again, what are we going to do? Factor the denominators, see what's up. And it's the same basic idea if we're adding or subtracting. So if we look at number 35 or 735, 1 over m squared minus m minus 2 plus 5m over m squared plus 3m plus 2. Step 1 is going to be to factor both of these. So this one's going to be again, if you see that instantly, awesome. If you don't, you can go and use the equation we've been dealing with. Over here, m plus something and then m plus something else. What are two values that when we add them together become 3, when we multiply them together become a positive 2? So our common denominator for both of these is going to be m minus 2 times m plus 1 times m plus 2. Because we're adding, we can do that. Going to put the 1 out in front here. What thing down here is this denominator missing? It's the m plus 2. Over here, what part of the denominator here is this thing missing? It's the m minus 2. So now we've got 1 times m plus 1 times 2 plus 5m times m, 5m minus 2 combine the like terms, 5m squared, negative 10m plus m, so negative 9m plus 2 over m minus 2, m plus 1, and then m plus 2. We can factor the top, see if it'll cancel out with anything on the bottom. It might not, but we know how to factor that right at this point, right? So look at 738 and try to work that one out as the in-class problem. to help out with this one, I'll even say get back for anything else from there. And something to think about as well. When you're looking at these, we're probably not gonna have anything that cancels out whatever we have on the bottom. So I'll just come out and say, when you have your final answer, that's what the denominator is actually going to look like.
I come from the translate I had a negative 3 becomes C plus 3.
Well, because we got the C minus 3 multiplied over here. So distribute the 3. So 3 is E. And then negative 3 times 3 minus. So negative 9. And then let's try to make sure that I wrote it down correctly. So you can pull the
negative 3 out.
Maybe you can cancel something out there. Let's see, minus. Oh, good. It's a thing. Okay.
Do I have to go for this?
All things that you have there, Susan.
Which one extremely similar.
So there's people 6 there. So that's going to change things a little bit. Okay, it's going to change things a lot compared to what you've got there. Yeah. Oh.